Welcome back, everyone. And welcome to the first tutorial. Well, the first actual tutorial, the first actual video of this series. Now, this time we're going to be talking about variables. Now, maybe my audience hasn't taken algebra yet. Maybe they have. Probably learned this stuff in pre-algebra as well. So I'll go ahead and explain what I have here so far. Now here's your standard line formula. I think it's slope-intercept form. I think. Basically, if you're given a slope m and a y-intercept b, you can find any point on a certain line based on the slope and the y-intercept. Because then you can just plug in a number for y or x, and there you go. You got a point somewhere on a line. Now, the second formula here I have is the area of a two-dimensional rectangular figure, aka rectangle, square, rectangle. But pretty much all these formulas, as you see right now, have what are called variables. Now, in mathematical terms, a variable is just something that holds a number. Now, this number could be 3.14 blah 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 blah, which is pi. You could have e 9.8 meters per second squared, which is the acceleration due to gravity. You learn that in physics, but you can have 2, 3, 0, it goes on forever. But the basic concept of a variable is some sort of storage container. You can think of it like a box. Let's say these squares are the container for something. Now, this box has a size. So let's just put in there it has a size property. Actually, let's go into a new tab so you don't see all these formulas. Alright, we have this box. It has a size. The size is equal to, I don't know, I like a size 4 box. Why not? So we have this box. It has a size of 4, so that means we can fit something that's of size 4 in this box. Now, in this tutorial, I'm also going to go over not standard. I guess you can call them standard, but they're not in every language. Some languages you can use universal. It's just like, here's a variable. Alright, but let me get into what I'm going to be talking about. I'm going to talk about I don't want to call them standard because they're not standard, but basically types of variables. Now, first of all, you have your character. Now, in most languages, this is represented as the char. You have your wide character. I can't type. Which which you probably won't use. So I'm just going to go ahead and delete that. The next thing you're going to use that's pretty standard is your integer type. Typically standard is int. Pretty much the thing. Now, pretty standard. Now, along with ints, you have. Now, I want to stick with ints for a moment. Ints are any number between negative infinity and positive infinity, meaning one thing. Well, not meaning one thing, but there's only one condition. They can only be whole numbers. So let's pretend wow, brain failed completely right now. The percentage sign is infinity for a moment. We'll just use. Alright, here's a great example of a variable. Now that I think of it. Alright, let's say we want a number between, say it has to be, that. Here is a great example of where a variable comes in. N has to be less than 8, but greater than 1. So n can have any value between 7 and 2, or 2 and 7, whichever you figure out you want to do. Maybe you want to write it like this, or some other way, or maybe you want to be funny and make it weird. But there is a great example of what a variable can be used for. Now, along with your integer types, which are all whole numbers, you also have the unsigned integer, which is typically represented by either using unsigned or unsigned. I should probably put a comma. Blah blah blah. Yeah, I can't type today. Unsigned or unsigned int, either works. That's what they're typically done in. But some if I go into something like Python or some scripting languages, typically you'll have pretty much what are called generic variables, where the compiler or whatever. I'll get into this stuff later, but there's a thing called the compiler, or you'd have some kind of script reader which figures out what variable type it is in the background. I won't get into that stuff, but yeah. Now, they're very similar to ints, except for one condition. It can, instead of being from negative infinity to positive infinity, all whole numbers, it can only be from 0 to positive infinity. Basically, you don't have a minus sign. The greatest example of what can be fit in here is anything you can put in it between that. Now, for anyone who doesn't know what that is, that's the absolute value function in mathematical terms. In most programming languages, it's typically done something like this. ABS for absolute value, then takes a parameter of some integer, float, or whatever type. But yeah. Now, the next one I'm going to talk about is the floating point number. This one has a few types because, alright, what a floating point number is alright, we have this box. You're not going to fit every single point, like, let's say you have pi, for example. You're not going to fit pi inside of a box that's size 4. You can try, it's not going to work. So whatever your language does, most languages handle floating point stuff like that all the same way, but it'll try to match as precise as possible that value that you're trying to put inside that box. Now, there's multiple types of floating. Well, there's not multiple types, but there's different sized boxes for floating type numbers. The typical first size is the float. Second size is typically the double, and the third size is typically the long double. Now you're probably like, okay, when do I use a float, when do I use a double, and when do I use a long double? Very, very simple. You use a float when you're trying to do something very simple, and preciseness probably won't be a problem. You don't really care about that much. It's like doing 1 divided by 2. You like storing half. A float would do pretty good job. You ain't going to be using a long double for storing 0.5. That's kind of insane. Now, on the other hand, a double and a long double are used for storing either really big numbers or really, really, really small numbers. Like, trying to think of a good example of a small number you throw in something like a double. Can't think of any off the top of my head, though. Now, let me put it this way. If you're dealing with money, you want to be as precise as possible. So chances are, while floats would probably get the job done, you don't want to lose decimal points. So you either would do two things. Now you could either use a long double, or you can create your own data structure, which I'll talk about later. You saw in the other things like you have your data structures, and that's in the advanced tutorials. But pretty much you'd probably use a double, so you don't, because you're gonna want that 1/1000th of a penny. You're like, it's a penny. Well, it matters. Trust me. Sure. Anyways, now that we got that out of the way, next type we got is a Boolean. Typically the most oftenly represented by the bool. Now, some use the entire word, okay, but typically represented by bool. Boolean has two values, true or false. Very simple. True. I can't type for crap today. But true or false? Pretty simple to understand. And I'm trying to think of what else you might need to know. But yeah, I guess I'll go into it. Now, it's not technically a data type. Now, some languages, I think Java and most generic languages will consider this a data type. But some languages like C++, it's a data structure, not a actual built-in type. And that's called string. Now, what a string is, it is not a data type. What it is a concept. Okay. What a string is, it is a list of characters. I think that's the best way to put it. Now, you're probably wondering, how do we make lists? Now, I'll just jump into this topic real quick. I'll just delete that stuff. I'll leave it. Let's go to a new tab. There's a concept in variables called arrays. So let's say, alright, I'll type it out so you guys know what the hell I'm talking about. But what an array is multiple instances of the variable with the same name given offset by a certain number. Like, for instance, if I'll use an int array of 3 for a 3-dimensional point or something. You wouldn't type and create 3 different variables. It just doesn't make sense. Unless you're creating a data structure, then it makes a little bit more sense because you only have to type them all once. But if you're just doing something simple like throwing something together, you'd probably just use an int3, but you'd remember put a name on it. Like this right here would be a syntax error in probably most languages. So we have that's pretty much the generic layout. There's some other stuff like semicolons in some languages. I know Python does line breaks and tabs. Java does semicolons too. But pretty much that's what an array typically looks like. And then what you do is basically, alright, I want to access the first element. I want to access the second element. I want to access the third element. I want a compiler error. Now, I haven't talked about a compiler before, but pretty much put it this way. When you create an array in most languages, it does not start at 1. It starts at 0. So if you create an array that's 3 ints big, you are from 0 to 2, not 1 to 3. So pretty much, if you try to use this, you would get an error. Now, depending on what language you are using, this may or may not be actually considered an error. Some languages will allow you to get away with this because they don't care. Now, your operating system cares, and it's going to throw this big error at you saying you're accessing memory that you're not supposed to. And I'll get into this type of stuff in a later lecture. Probably if I do more after the ones I've already done, like these. I'll talk about what's called casting. Casting's really fun because pretty much what it does is it takes one data type and turns it into another. But that will be enough for this section. So let's just have a quick review. Alright, so what a variable is? A variable! Yay, variable! It is a storage container with some size equals some size. It can contain some type of data. It could be a int. It could be a float. When you get into that, and when later we get into data structures and stuff like that, it could be your entire window. Or it could be your entire game. Now, the chances of it being your entire game are very slim because a game is a very big thing. Like, what is it? Like, average game size now? Like, 12,000 kilobytes? No, that's not happening. Now, for people who are trying to figure out how big 12,000 kilobytes is, it's this. Try and put it in my head. 2 to the... That? Yeah, that sounds correct. It's 12 times 2 to the 10th power. That's a lot of that's a lot of bytes. Alright? Maybe at some point you like, yeah, if I'm doing sizes, I probably, yeah, no, we'll we'll push it off. Maybe I'll talk about when I get. Yeah, I'll talk about that when I get into memory. But until next time, we will play around with the concept of variables. They are very, very useful, and you will see why in a bit. So see you next time.